Hey everyone, it's Mr. Rosen here again. Today's video is going to be about probability with normal distributions. So with the normal distribution, almost everything in nature follows the normal distribution, also known as the bell curve. And the example I'm going to give you is going to be about gene sizes or pant sizes. So let's say that I work for a company and I find out that I do a bunch of surveys and I ask people what their pant size is. And I find out that the mean pant size, I'm going to use this symbol, which is mu. Okay, the mean pant size is going to be 36 inches. And then I do some more surveying and I do some calculations. And then I find out that the standard deviation is going to be 2.5 inches. So what does this tell me about my genes that I need to be making? Okay, what I know is that 95% of people will fall between 36 plus or minus 2 times the standard deviation. And you can work out that range. Okay, and that only occurs when things are normally distributed. So if you actually were to graph this thing, right around 36 here, the frequency would look kind of like this. Okay, so the majority of people are going to be around 36, 34, 38. They're going to be in this sort of middle range here, okay? Some people are going to be more on the extreme side on the right. They're going to have larger waists. They're going to be at the 40, 41, 42 area. And people who are smaller are going to be on the left side. They're going to be the 28 to 26 inch waists. Now, let's say we know these two facts. We've got the mean and I've got my standard deviation. We can actually work out probability of certain events occurring. As long as we know that it's normal, we could do this. If it's not normal, this won't work. But if it is normal, then we could do some different calculations. So here's our first example. First one is, what is the probability of somebody having less than a 40-inch waist? So that's what this means. So the probability of X being less than 40. So what is the probability that someone is less than 40 inches? Now, in my graph here, let's sort of assume that this right here, that marker is 40, okay? I want to know what's the probability that someone is less than 40. So they can fall anywhere in that curve. I want to know what's the probability of that occurring. Now, if you were to make a relative frequency graph, you maybe could do this, but basically you got to figure out the area of that thing, the area under this table, under the curve in this spot here. That's very, very difficult to do. Now, mathematicians, though, have figured out a way of doing this. And what you could do is you can basically figure out the z-score or the z-score for 40. And once you know that, you can look it up in this standardized table that mathematicians have generated. And once you look it up in the standardized table, the area on the standardized table or the standard normal table is going to be the same as this area inside of my table here, of my graph. So the process is really simple, and I'm going to show you how to do it. Okay, so we want to find the probability of X less than 40. What I'm going to do over on the side is figure out the z-score, the z-score for that. And the formula for the z-score is going to be X minus the mean over the standard deviation. In this case, my X is 40. My standard deviation is 36. Sorry, my mean is 36, and my standard deviation is 2.5. So when I work that thing out, I end up getting 1.6. Now, I would recommend you go to 2 decimal points here. Okay, now it just happened to work out to 1.60. So if we go back to the left side here, this question says probability of X less than 40. What I can say is that that is exactly the same as the probability of Z being less than 1.6. Those are equivalent. Okay, what I've done is I've worked out the z-score for that value, and I've rewritten it in this form here. Now, what do we do with this? Okay, most textbooks will include, usually at the back, this thing called the normal table. Now, I'm going to show you what it looks like. I have a PDF version of it. It might not look exactly the same as what your book looks like. Sometimes it's more like a chart, okay? And in the book that I currently use, it's got 2 pages. And what this is this is a list of Z-scores here. They're in bold. And then it says the area beside it. that area represents the probability of that thing occurring. Okay? So, when I go back, and what was my number there again? So the area I'm looking for is z less than 1.6. So I got to find that in my table. Let's find 1.6. So these are the negatives. It's not over there. Okay, 1.6 for me is right here. 1.6 is right there on my table. So the number I got, the area under the curve at the z-score of 1.6 is 0.9452. Now, how they generated these numbers, I have no idea. These are some very smart mathematicians that solved this stuff. They probably use computers to figure this out, because getting all those little individual areas is very difficult. So they made this table to make it a lot easier for us to actually work these out quickly. So that's my number. So the area under the curve when the z is 1.6 is 0.9452. So let's go back to our question. And that's what we're going to say. So this is going to equal to 0.9452. And that's the answer to the question. So therefore, the probability of someone wearing less than size 40 pants is 94.5%. I just turned that into a percentage. That's how you work it out for something simple like that. Now, what if you want to do a greater than sign, okay? Greater thans are a little bit more difficult, okay? But not by much. So let's say I want to know what's the probability of somebody, so x being greater than 33. So somebody being greater than 33 inches. Now again, if we look at our normal curve here, okay, our mean is at 36, so it's going to look kind of like this, right? And 33, I'll do in red. 33 is right here somewhere. And what we're doing is we're doing greater than 33. We're doing the right side here. Okay. This is a bit of a challenge, because when we look at these tables here, the one in my textbook, the scanned in version here, this is always the area less than these values. Okay, so when we work out, let's say, we get a number like 1.5 for a z-score, right? And we work out our little normal table here, whatever it might look like. It is always the area less than it. It's always the area to the left. Okay, so in order for me to figure out the area on the right, what I have to do is I have to go 1 minus that to actually figure out the proper answer. So these are always the area less than the values that are shown. So for this question, the very first thing I'm going to do here is I'm going to rewrite this. So I'm going to write that the probability of x greater than 33 is going to be the same as 1 minus the probability of x less than 33. So basically, instead of solving this red version that I have here, okay, essentially what I'm going to do instead, here's 36, here's 33. What I'm basically going to do is figure out the area to the left of 33, that little purple area, and then subtract it away from 1, and that will give me what's left, which is going to give me the red stuff, which I'm looking for. So you got to change the direction of the greater than symbol to make it into a less than symbol, just like I did here. Now, once we've done that, what I'm going to do is figure out the z-score, the z-score for 33. So on the side, I'm going to write z equals 33 minus my mean, which is 36, over 2.5, which is my standard deviation. When you work this out, you get negative 1.2. Okay, negative 1.2. Now, what do we do with this? We are going to rewrite this equation right here, and we're going to write 1 minus the probability of z, or z, less than negative 1.2. So this is equivalent. It's the same exact thing. It's just been converted into this z-score instead. Now, what we can do with this is we're going to go ahead and look this up in the table now. So we're looking for negative 1.2. So let's look in our table. And this time we're in the negative, so we're going to look for 1.2, which is right over here on my table, negative 1.2. And the answer you get here, the area there, or the probability of that occurring, is 0.1151. So let's go ahead and write that in. So this is the same as 1 minus 0.1151. That is the probability of z being less than negative 1.2. Keep saying z because I'm Canadian. I know in America and place they call it z, but same thing. Okay. So now we're just going to do our final subtraction here, and we end up with 0.8849. And that's the answer. So therefore, there is an 88% chance someone wears size 33 or more. Or over a size 33, I should say. Okay, over a size 33. You get the idea, though. Okay, 88% chance that occurs. So that's what happens if it's a greater than symbol. Now, one last example. So let's say I want to do a range. So the last example would be, let's say I want to know what is the probability of someone wearing between a 32 and a 37. So the way I'm going to write it is I'm going to say 32 is going to be less than x, which is less than 37. So I want to solve that. So what I want to know is basically what's the probability that someone wears between 32 and 37. So in my graph, what it's going to look like here, here's 36. It's going to look kind of like this, right? So here's 37. We're going to kind of exaggerate it a bit, but there's 37, there's 33 or 32. And what I'm looking for is the area right there. Okay. Now, how are we going to actually calculate this? One thing we got to remember is that with the normal table that we're going to be using, those values are always less than. They're always less than. So the idea here, the way we're going to solve this is this. We're basically going to figure out the area at 37. Okay, that's going to give us all of this. And then what we're also going to do is find the value at 32, which gives us this purple stuff here. And we're going to subtract them. So we're going to figure out the probability of the 37, and we're going to subtract away the probability of 32, which would leave us just that middle red area. We subtract away that purple spot. That's the logic of it, at least. Okay. So the way I'm going to do this is this. So I'm going to rewrite this and say that this is the same as the probability of x less than 37 minus the probability of x less than 32. Oops, 32. You want to have the one on the right minus the one on the left, basically. Okay. Now for each of these, I'm going to need z-scores because I got to rewrite these things. So I'm going to do them over on the side here. So let's do the first one. So z is going to be 37 minus my 36 was my mean over the standard deviation of 2.5. You work that out, you're going to get 0.4. There's the first one. Let's do the other one now. So z is going to be 32 minus 36 over 2.5. So I'm just doing the same process here. And this one ends up being negative 2.67. This one goes on forever, so you want to round it to 2 decimal points here. Now I've got my two z-scores here. I'm going to rewrite my equation up. I'm going to write the first one is going to be probability of z less than the 37 one, which was 0.4, minus the probability of z less than the 32 one, which was negative 2.67. Be very careful with a question like this. I've seen lots of times where people will mix these up. They're going to write the wrong z's in a wrong order. You got to make sure the one on the left, this was the 37 one. I got to write the z-score that goes with 37. The one right over here, it was the 32 one, and you have to match it up with the z-score for 32. All right, so we've got it set up properly now. Now we can go and look at our table. So the first one is 0.4. Let's go back and look at the table here. Let's find 0.4. And it's right here. So 0.4 gives me an area of 6554. So let's go write that in. So this would be 0.6554 minus the probability of z less than negative 2.67. Let's take a look for that one. Negative 2.67. 2.67 is right here. It's a very small probability of that occurring. Okay, so that's 0.0038. Okay, 0.0038. And that's very unlikely, right? If you look at that, it says the probability of, this is x less than 32. That'd be someone having less than size 32 pants. Very unlikely based off of our standard deviation for this question. And that's it. So let's subtract them and get our answer. So 0.6516 is the answer. So therefore, there is a 65.2% chance someone wears between 32 and 37-inch pants. So that's how you work out probabilities using normal distributions. And again, this technique only works if it is normally distributed. If it's not normally distributed, there's different things you have to do. And there's different techniques to solve in those type of questions. But if it is normally distributed, what you have to do is you have to basically figure out the z-score for your value and make sure it's a less than symbol. If it's right, if it's greater than or whatever, you have to convert it. But if it's a less than symbol, convert it to your z-score. Once you get the z-score, use your normal table to figure out the area under that standardized curve, and that's how you work out your probabilities. So hopefully you learned a little bit about working out probabilities with normal distributions, and hopefully this helps you out with some questions that you may have in the future.